In this video, we are going to understand knowing HCF of two numbers with the help of Euclid's division lemma. Actually, it is based on activity that is expected to be done by the students of the standard 10. So, first of all, we are going to learn rather something to know about the Euclid's division lemma. According to Euclid's division lemma, if a and b are two positive integers, then there must exist some whole numbers q and r such that a is equal to bq plus r, where r is greater than or equal to 0 and less than or equal to b. First of all, we should understand the statement. First of all, the noting point is this. This Euclid's division lemma is not true for only the positive integers. Actually, it is true for all the integers and also for the polynomials. So we should keep it in our mind that it is having a wide canvas, broad canvas. Okay, so actually here we are only supposed to go through the Euclid's division lemma for only positive integers, because in the syllabus of standard 10 we are to understand this one only for the positive integers. Okay, positive integers, that means the natural numbers. Here what the statement says, what is the basic thing, what is the basic fact behind this lemma is this. It is said, it says that if we are having two positive integers, then one of them can be divided by another. This is the basic fact behind this one. And actually this is the division's definition in terms of multiplication. Actually, the first time Euclid had given the definition of division in terms of multiplication. So actually it is definition of division in terms of multiplication. And again I am repeating that it says that if we are having a and b, two positive numbers, then we can divide b by a or a by b. Okay, so why we will have some quotient q and some remainder r. So now it is written in terms of the multiplication. This a is called dividend, to which we divide, and this b is called divisor, by which we divide to this a, and this is the quotient. That means how many times we multiplied b for this purpose of division, and this is the remainder. So what we got is the remainder. What is the left out number is called the remainder, and we can clearly see that this remainder will be clearly less than, or less than, sorry, it will never be equal to b, it will be always less than b. So actually this r is greater than or equal to 0, but less than this b. So here this b is always greater than the remainder, otherwise the division process will not end, it will go. So okay, so this is the division lemma given by Euclid, and now we could understand what is the sense behind this one. Actually it's a division process, and now with the help of this definition of division we could know the HCF of two numbers, and this is the basic thing of the activity. Actually this activity shows that we can easily find with the help of this fundamental process the HCF of given two numbers. For that purpose we need some activity, and for that purpose we should have a cardboard, some colored chart papers, so that we can perform this activity. Here I could make this one for you. Here we took two lengths having some units of length. First of all, I should measure this one. So actually this one is of 16 units, and again this is the second one is of 12 units. So the length of this one is of 16 units and this one is of 12 units. And now we want to know the HCF of these two numbers. For that purpose, first of all we will divide the longer one, the greater one, by the smaller one. And so we did, and we got some remainder. Clearly, some part of this rectangle has been left out. And now we measure to this part, and this is the part. And now with the help of this, we divide to this one. So for that purpose, we divided. Then we got that it is clearly divided, rather perfectly divided by this length, having quotient 3. Having quotient 3. Okay. So now we could understand that this length will be the HCF of these two lengths. Okay. So now we should measure these two lengths to have the answer. First of all, I have shown with the activity that this particular length has completely divided to this blue part of the rectangle. So this is perfectly now divided by this one, and now we can conclude that this is the HCF of these two. And now, as we were already measured the lengths of these two, this was of 16 and this was of 12, and now we want to measure the length of this rectangle. For that purpose we use the scale, and it is of 4 units. So it is of 4 units, so clearly HCF of 12 and 16 is equal to 4. So with the help of this activity, we could know about the HCF of given two numbers, and in this process we use the Euclid's division lemma. And I think this is not good enough. Now I am taking another example to show this. So take another example. Again, I measure the length of these two. Okay. So actually, it is of in this example, this one is of 15 units and this one is of 9 units. So this one is of 15 units and this one is of 9 units. So now we want to know the HCF of 15 and 9. For this purpose, first of all, we will divide the longer one by a smaller one. For that purpose, we divided the longer one by a smaller one, but this is not perfectly divided. There is some remainder. So to measure that remainder, I took another rectangle. So this is the remainder, and now we want to divide to this part by this remainder to know. In the process of knowing that one, we divided to this one by the remainder and got again some remainder. So again, it is the work is not finished. Again, we need to divide the this remainder part by the remainder which is here to be made. So now we took a remainder. This is the remainder. This is the region that was left out. So now with the help of this one, that is called remainder when this one is divided by the green rectangle. So now we will divide to this rectangular part by this remainder part, that is the reddish part. And now when we divided by this one, we divided by this one, we divided by this one, then we got then we got then we got that when we divided by this one, then we got that this one is completely divided by this having the quotient 2. And now we will say that this is the HCF of these two numbers. How this one is, we must check it. first of all we will show that this completely divides to the yellowish rectangle, and then we will show that this will completely divide the bluish rectangle. Look here. Here we divided to the yellowish rectangle by that red smaller rectangle. Then we got that it completely covers this one. That means it divides perfectly to the given rectangular part. This one. Okay. So this is being divided by this rectangular part completely. Now we'll check the same thing for the bluish rectangle. Again we got that this part was completely divided by this rectangle having 3 at a time. And now we clearly see here this bluish rectangle is also completely divided by this particular length. So we can say that this length, this one, is completely dividing to both of them. So now we want to measure them to know what is the length, and we understand that this is the HCF of these two numbers. So we want to know the length this time. For that purpose we will measure them. We will measure them one by one to know the HCF. Here we got that the length of this one is of 15 units, and the length of this one is of 9 units, and the length of this one is of 3 units. 3 units. So now we can say that this is the HCF of these two numbers. Okay, so we could get the process. First of all, we divided to this 15 by 9, and we got quotient 1. The only one rectangle was there. Only one rectangle was there. Okay, there only one rectangle was there. So we divided by this one by the bluest rectangle. Then we got the quotient this one and the remainder of 6 units. Clearly you can measure the length of another part of this one. This remainder part can be measured. That was the remainder part. Again we can measure to this part. Clearly it is of 6 units. So we could note that the fundamental process of knowing the SCF. We got 6 as remainder. Now we divided this 9 by 6. Okay, we divided this 9 by 6. Here, this 9 is divided by this 6. Then we got some remainder. Okay, some remainder. And that remainder is again equal to 3 units. So now we can write that quotient is 1 and the remainder is 3 units. And now we will divide this 6 by this remainder. So it will be 3 times 2 plus nothing. We should check this one again with the help of the activity. Clearly you can find that this was of 6 units and this was of 3 units, and clearly you are visualizing that there are two such strips, two such rectangles. That means this 6 is divided by 3 by taking 2 units. That means the quotient this time is 2. So we got this one, and finally we say that its CF of 15 and 9 is equal to this one, the last one, this one, and this is the answer of this. So with the help of Euclid's division lemma, we conducted an activity to show that its CF of two numbers can easily be found, and hopefully you could understand this one, and will perform some activity. We need something. We need a chart. We need a board. Any board you can take, that would have been plain one, and you can take some colored papers. If it is glazed, it has some glazing, it will be better for us to visualize that one. So with the help of those and having scissors, scale, you can perform this activity and could by doing yourself know the fact. Okay. Have a nice day. Thank you.